Hello friends, in this video we are looking why we need CPU scheduling algorithm. Generally in multi-programming environment, multiple processes like P1, P2 and so on Pn will be reside in a RAM. Assumes we are using a single core CPU. But nowadays, we are using multi-core CPU, which will take multiple processes at a time and processing it. But here, we are using single core CPU, which will take only one process at a time among multiple processes which is reside in a RAM. But the question is how to select a single process by the CPU. CPU select randomly? No, not at all. CPU select a single process among multiple processes based on some policy or algorithm. That policy or algorithm is called CPU scheduling algorithm. Here CPU scheduling algorithm come into the picture, but anyway, a good CPU scheduling algorithms always keep some criteria. The first one is CPU utilization. CPU utilization, which means out of total time, how much time CPU will be useful for, for in our algorithm. Suppose a processor P1 executing on CPU that need input data. That time CPU is ideal. A good CPU scheduling algorithm does not like if CPU is ideal. So rather than CPU is ideal, CPU select another process and executing it. Once the input data ready for the P1, CPU brought P1 again and executing it such a way that our algorithm is always keep CPU busy as much as possible. So a good algorithm always keep CPU utilizations will be high. And the second criteria is throughput. Throughput means out of particular unit of time, how many number of process are completed. This throughput also should be maximal. Examples, out of 10 unit, 7 number of processes are completed in algorithm A. Algorithm B, out of 10 unit, 6 number of processes are completed. Now clearly algorithm A is a first and algorithm. And third one is waiting time. Generally, in multiple programming environment, multiple process which is reside in a RAM. So waiting time means how much time a process waiting in the ready queue which is reside in a RAM. That is called waiting time. For simplicity, this is the RAM processor P1 and P2 and P3. Assumes they are using a single core CPU. So at the time only one process are executing. Suppose CPU selected processor P1 and executing it. At a time P2 and P3 should be waiting. This time is called waiting time. which means how much time the processor waiting in the ready queue which is reside in a RAM. It is called waiting time. The waiting time should also minimal. And fourth one is turnaround time. Actually, generally in multi-programming environment, initially multiple processor will be reside in a hard disk drive, like processor P1, P2, P3. Later, during runtime environment, this process moved from hard disk to RAM, like processor P1, P2, and P3. So this moving times, which means whenever process moving from hard disk to RAM, that arrival time into the RAM is called arrival time. Suppose processor P1 is arrived into the RAM at 11 o'clock. And here we are using the single core CPU. So CPU select P1, which will need some input data. Now at time CPU is prot P2 and executing it. Once the input data is ready, then this process will be brought into the CPU again and executing. Then the process will be going to the output devices and successfully terminated. This is called completion time. Whenever process arrived from hard disk to RAM, this is called arrival time. So turnaround time will be calculated is equal to completion time minus arrival time. Here assuming completion time is 11 o'clock 5 minutes, which means 11 o'clock 5 minutes, and arrival time is 11 o'clock, then turnaround time should be a 5 minutes. This turnaround time also should be minimal. And one more thing, waiting time will be calculated by turnaround time minus post time. Here post time means CPU execution time, but the question is how to calculate the CPU execution time for the particular process before execution. This is also very challenging task. But anyway, here we are only calculated waiting time. Waiting time means turnaround time minus post time. Already we calculated turnaround time, then subtract post time. We can calculate waiting time. This waiting times also should be a minimal. So finally, conclusion is whatever algorithm designed and developed which always keep CPU utilizations and throughput should be a maximal, as well as waiting time and turnaround time should be a minimal, such a way that CPU's algorithm already designed and developed. Thank you.